You tap an address and instantly a glowing blue dot appears on a map telling you exactly where you are. Whether you're navigating a new city or tracking your run, your smartphone seems to have this magical ability to pinpoint your location. It's one of the most incredible technologies we use every day, making seamless navigation a reality. It feels like magic, doesn't it? But it's not magic, it's science. It's a spectacular symphony of incredible engineering, super precise clocks, orbiting satellites, and even the profound Albert Einstein's theory of relativity. Today, we're diving into the real science of how GPS works. By the end, you'll never look at that little blue dot the same way again. First things first, what is GPS? GPS stands for Global Positioning System. It's a network of about 30 satellites orbiting Earth at around 20,000 kilometers up, or 12,000 miles. That's like twice the height of a commercial airplane flight, but way higher. These satellites are constantly zipping around the planet, completing 2 full orbits every day. These satellites are more than just powerful broadcasters. They are essentially super precise clocks. Each one is a marvel of engineering, equipped with incredibly accurate atomic clocks, calibrated to within a billionth of a second. Without that breathtaking precision, the whole system falls apart. These satellites aren't listening to your phone. They're constantly broadcasting down to Earth. What are they saying? Just 2 vital things: their exact location in space at that moment and the exact time they sent that signal, based on their atomic clock. Now, how does your phone tap into this? Inside your smartphone is a tiny GPS receiver chip. It doesn't send signals back up. It's just passively listening, like a receiver tuning into a radio station from space. Now, here is where the math happens. The fundamental principle at work is called trilateration, the science of finding a position based on distances. Think of it like this. Imagine you are blindfolded in a big open field. 3 friends, shout now, at the exact same moment from different known spots. You know the speed of sound. If you measure the time it takes for friend A's shout to reach you, you can calculate the distance to them. This puts you somewhere on a circle around them. A second friend's shout creates a second circle, and the only possible places you can be are where those 2 circles intersect. A third friend's shout finally narrows it down, pinning your precise location to a single spot. GPS works the exact same way, but with radio waves traveling at the speed of light, and the friends are satellites in space, your phone calculates the distance to each satellite based on the measured time delay. Since we live in a 3D world, this creates spheres around the satellites, not circles. 1 satellite puts you on the surface of a sphere. 2 spheres intersect to form a ring. 3 spheres intersect to give you 2 possible points. 1 usually way up in space, which the system discards. In reality, for a 3D position, latitude, longitude, and altitude, you need at least 4 satellites. Why 4? The 4th accounts for any tiny timing errors between your phone's cheaper clock and the satellite's atomic ones. The problem isn't the satellites, it's your phone. The atomic clocks in space are incredibly accurate, but the clock inside your cheap, everyday phone is imperfect. Even a tiny error, a mere millionth of a second, could throw your calculated distance, and thus your location, off by hundreds of feet. This is where the 4th satellite comes in. It acts as a sanity check, or a timekeeper. The signals from the first 3 satellites tell your phone where it is, assuming its clock is perfect. The 4th signal gives an inconsistent distance, allowing your phone to immediately calculate its own clock's error. By solving a system of 4 equations for the 3 dimensions, latitude, longitude, altitude, plus the 1 unknown variable, the time error, your phone effectively makes its cheap, imperfect clock as accurate as an atomic one, correcting that error on the fly. But wait, GPS isn't perfect alone. In cities with tall buildings or indoors, signals can bounce or get blocked. That's where your phone gets smart with assisted GPS, or AG. It uses nearby cell towers and Wi-Fi networks for a quicker fix. Cell towers act like local beacons, giving rough location data, while Wi-Fi hotspots have known positions in databases. Your phone combines all this for accuracy down to a few meters. As if that wasn't complicated enough. There's a hidden layer of profound science that GPS must account for. Albert Einstein's theory of relativity. This is not science fiction. It is proven physics that affects the very timing of the system. Engineers must make 2 critical relativistic corrections. Special relativity. The satellites are moving incredibly fast, around 14,000 kilometers per hour, causing time for them to run slower than time on Earth. General relativity. The satellites are in a weaker gravitational field, which causes time for them to run slightly faster. Satellites move fast, so time dilates slightly, and gravity affects clocks too. The net effect is that the atomic clocks on the satellites are running about 38 millionths of a second faster per day than clocks on Earth. If GPS engineers didn't account for this tiny but massive error, your location would drift by several miles, or up to 10 kilometers, approximately 6.214 miles every single day. They build these physics tweaks right into the software, correcting the frequency before the signal even leaves the satellite. It's quantum physics keeping your Uber on track. So the next time you see that blue dot guiding you, remember, it's not just a simple signal. It's a beautiful, massive, free global utility powered by precise satellites carrying atomic clocks, clever math known as trilateration, for signals to solve the clock problem, and the very fabric of space-time, thanks to Einstein. It's a truly mind-boggling piece of technology that works seamlessly in the background of our lives. If you found this explanation fascinating, hit that like button. And for more clear explanations of the incredible tech and science all around you, subscribe to Tech Science Explained. What's your favorite GPS story? Drop it in the comments below.